and today we have secondary alkanols. And let us see the behavior of secondary alkanols when they are oxidized with either potassium tetraoxomanganate 7 or potassium heptaoxo-dichromate 6, which are these: KMNO4 or K2CR2O7. Let's see the behavior of this strong oxidizing agent, acidified strong oxidizing agent, with secondary alkanols. And one of the examples of secondary alkanols, of course, I have classified all these we know we have today, is propane to oil. So let us see what happens when propane to oil reacts or undergo oxidation with potassium heptaoxo-dichromate 6. So let's see. Remember that this is a secondary alkanol. In our secondary alkanol, we all know that they have, or secondary alkanols have, 2 alkyl or phenyl groups, okay? And the OH functional group is attached to the CH atom, carbon hydrogen atom. So now we have our C, we have CH3, we have CH3, we have our H, and we have this attached to what? To OH. So this compound, we write it this way, or we can say CH3, CHOH, and CH3 is the same. This or this is the same. 1, 2, 3. 2 oil. This is propane to oil. It is a secondary alkanol. So when it undergoes oxidation, remember we are having CR2O7, and we have this, because what is being lost is 2 molecules of hydrogen atoms, or 2 molecules of hydrogen, or 2 atoms of hydrogen, as the case may be. So when these secondary alkanols are oxidized by this strong oxidizing agent, their corresponding alkanones are formed. Their corresponding alkanones are formed. Look at what we are going to have. We are going to have propanone. And that is why we say that their corresponding alkanones will be formed. So this is propanone. And this propanone is under ketone. We call them ketone, or we call them alkanones. We call them ketone and alkanones. So this is propanone. So that is the compound form. So secondary alkanols are oxidized to their corresponding ketones or alkanones, and propanone is formed. It simply means that this compound lost 2 atoms of hydrogen, or 2 molecules of hydrogen. So primary alkanols will give us ethanoic acid, while secondary alkanols will give us their corresponding ketone. So if this is maybe butane to oil, it will also give us butanone. Okay, that is exactly what it means. So they will give us their corresponding ketone or alkanones, and this is the product of the reaction. See you in my next class. But before I go, I've said it in my first class or second class why tertiary alkanols will not undergo this oxidation. Is because of, remember, the general formula for tertiary alkanols is R3COH. I told you this. This is the formula or general formula for tertiary alkanols. And you will agree with me that carbon has no direct contact with hydrogen atom. Like in primary alkanols we have R2CH2, RuCH2OH, while in secondary alkanols we have Ru2CHOH. So we have carbon to hydrogen bonding here. We have carbon to hydrogen bonding. But in tertiary alkanols, we do not have carbon to hydrogen bonding. And this is the reason why tertiary alkanols cannot, or they do not undergo oxidation